Generative DevOps. I am Cecelia Martinez McCrae. I am a lead developer advocate at OutSystems. Some of you may have already talked to me so far at this conference. I am based here in Atlanta. This is my, I believe, third year speaking at Devnexus, and really excited to be back here. I am an open source DevTools enthusiast. I've previously worked at on organizations like Cypress, an automated testing framework, Replay, a debugging tool, and then Ionic, which is a cross-platform mobile SDK. So I do have a special love for testing CI/CD and then web and mobile development. Here in Atlanta, I am the organizer for Atlanta JavaScript, which is a meetup group that meets every month. So if you are interested in attending any of those or speaking at any of those, we also do partner with Modern Web, which covers general web development as well. So please let me know. We'd love to have you showcase your skills for the community. This QR code goes to my Linktree, so you'll be able to connect with me on LinkedIn, GitHub, various social platforms, as well as get the slides for this presentation. I do post the slides from the talk at that QR code. So, as I mentioned, I am at OutSystems. So OutSystems is a low-code platform for developing full-stack web and mobile applications, as well as APIs and workflows. And it also handles the delivery and monitoring of those applications. If you'd like to learn more, we do have a booth here. You can come and stop by and ask any questions that you have. OutSystems is primarily used by enterprises to build mission-critical applications. But today we're going to talk about AI. So I'd like to start off by getting a sense of the room, and I want to get a sense of who is actually leading the AI initiative at your organization. So raise your hand if you feel like at your organization, leadership is the one really pushing to integrate AI into your engineering practices. Okay, good. I'm glad I'm seeing a lot of hands because that is what I have also seen from talking to a wide variety of developers. And that's also what we're seeing from surveys and data. Right, so we're seeing that 84% of C-suite executives believe that they must use AI to achieve growth objectives. And even more so, a majority believe that if they don't scale within the next 5 years, they risk going out of business. So there is a lot of pressure and demand to start implementing AI into software development practices as soon as possible in order to stay ahead of other organizations and competition and to stay relevant in the market. And leadership, not only do they have these expectations, but they have very specific expectations. So this comes from the Dynatrace report about the state of AI, and leadership has very high expectations of what AI can actually do. 93% expect that the speed of software deployment and delivery will increase by using AI. 89% expect faster incident response. 88% expect that we can extend access to data analytics to non-technical employees. 88% expect that teams will be able to predict and proactively resolve issues. And 79% expect that security analysts will also increase in productivity. So, just a few things here or there, but there's this idea that AI is like a catch-all for any problems across the entire software development process. But what we're seeing is that there's a lot of AI only specifically being used in one area of the software development lifecycle. And that comes with code gen. So 81% of developers use AI-powered coding assistants. Who here in the room has used code generation tools, whether that's Cursor, Copilot, ChatGPT? Right, so about 81% of the room. So that matches up with what we're seeing across the industry as well. And again, this includes things like asking ChatGPT to generate code for you. But it's reflective of how much usage has increased with software development. There's also associated productivity gains with this. So leveraging AI for development, they found that it results in productivity gains that range from 10% to 50%, depending on task complexity. So if it's a very simple task, you're more likely to see higher productivity gains. If it's a more complex task, then you're likely to see lower productivity gains. However, these productivity gains that happen within the coding part of the software development lifecycle can throw off the balance of the entire SDLC if you have constraints elsewhere in your system. So for example, if you're using code generation and you're generating a lot more code very quickly, But that could increase the number of potential security vulnerabilities in your system, and your processes may not be equipped to handle that or to scan for all that new code coming into the system. Or you may have a situation where you're generating code so quickly that your quality team can't keep up with the increased output of those code changes. You may also experience that if you're deploying more frequently, you may start to see incidents increasing, and you're not really sure why. You're not able to resolve those incidents as quickly as you would like, and you're not understanding why they have increased. So last year I did an earlier version of this talk where I advocated for the importance of not creating constraints within your software development lifecycle. And if you're increasing the output of one part of the cycle, but you aren't increasing output or efficiencies in other areas, then you're going to create bottlenecks that can actually restrict the overall productivity of your life cycle. And I apparently was saying something very obvious because this year when the State of Software Delivery report came out, the couple of things aligned with those findings from that in terms of some of the drawbacks of only focusing on code generation with AI. So in this report, they found that 67% of developers have actually spending more time debugging AI-generated code, and 68% of developers have spent more time resolving security vulnerabilities. Now, this isn't to say that it's bad to use code generation. It can obviously have those productivity gains, but it's clearly creating issues elsewhere in the software development lifecycle that need to be addressed. Otherwise, you will not actually be able to experience and take advantage and leverage those productivity gains. And a lot of developers agree with that. In fact, 95% of engineering leaders and 96% of developers say that the full benefits of AI-assisted software development will never be realized until their use extends to the entire software delivery lifecycle. So who here in the room has implemented AI in an area of your lifecycle that's not code gen at your organization? Show of hands. Few people, okay. For those of you who haven't, how many of you have seen some of these issues arise by using code generation in terms of having to debug AI-generated code or having issues with increased security vulnerabilities or other productivity blockers across your cycle? A couple of hands here, yeah. So there's definitely a disconnect here where we're focused on one area. So what we're going to do today is take a look at a few of the areas across the software development lifecycle where AI can be implemented in order to increase the overall productivity and efficiency of your system to complement and to some extent counteract increased code generation by using AI. So when we talk about design, the thing that's popular here is requirements and design generation, right? So using AI to generate requirements documents, use cases, and then even potentially UI and designs. There's also, we talked about code, right? You have code generation. You also have IDE integration for things like code suggestions to add new features when you're in your IDE. In testing, we're going to talk about autonomous testing and synthetic data generation. At the build step, you have automated review analysis. The deploy part of the software development lifecycle, we're going to talk about deployment, verification, and self-healing pipelines. And for monitoring, we're going to talk about prediction-based anomaly and detection and detection and agentic observability. Now, I'm not going to go into the design and code because I feel like those areas are pretty well tread, and I wanted to focus on the areas of the SDLC that are not covered as often and that are not currently being leveraged as much as they could be across the SDLC. So we're going to focus on test, build, deploy, and monitoring. So we'll start with testing. As I mentioned before, I come from a testing background, so I have a special place in my heart for testing. Any other testing fans out there? It's okay, there's dozens of us, I swear. And so when we talk about testing and integrating AI, obviously the first thing that people think of is, Copilot generates my unit tests for me. It'll write my test code for me. However, that is still considered code generation, so it could still have issues that are associated with code generation when it comes to errors, incorrect syntax, hallucinations, leveraging outdated APIs that are no longer in the framework that you're using anymore. You're still going to run into those issues when it comes to generating the code that actually runs your tests. So some of these new solutions revolve around autonomous testing and codeless test generation through app learning. So using generation tools to create the test code for unit tests, that still has a place within the cycle, but these are some new frontiers in terms that remove some of those limitations that come with test code gen. The way that these works is a couple of different features that are leveraged here. One is natural language processing for test case definition. The other is using computer vision selectors to adjust to changes. So how many of you have written tests and then had to manually update your selectors when a button changed or an ID was changed or some element on your page was removed? So what this does is instead it learns your application and uses computer vision in order to identify those selectors when you run your automated tests and update them accordingly by interacting with your application. So an example that we're going to talk about is AppFance AI, which uses test generation by interacting with your application and training on your application to create a blueprint file. So essentially what this says is you provide an environment URL or a build of your application. It uses automation to interact with your application like a user would, same way test automation does. But through that interaction, it's learning about the different user flows of your application, as well as the various selectors that are interactable on your page. It takes all that data and it creates what it calls a blueprint file. Okay, so it creates what's called a blueprint file, which is essentially, it's a model of your application and the various ways that a user would interact with it. It also takes advantage of that blueprint and server logs. So it captures your server logs to also understand the API interactions of your application. It uses those two things in order to create functional and API tests. You can also integrate this into CI/CD so that you can automatically retrain based on changes. So if you push a new feature, it'll interact with that new build. It'll find out anything new that it hasn't covered before, and it'll generate those new test changes. So you're going to hear kind of this idea around the testing portion where it's retrain, not maintain. So if you're able to leverage AI into your testing suite, instead of having to manually maintain all of these new use cases, all of these selector IDs, everything that you need to interact with to have a healthy, robust UI testing suite, instead, you let the model handle that and interact with your app, and then it retrains and finds those differences. There's also other autonomous testing tools that are leveraging AI. BrowserStack, TestGrid Code Tester, and Mabel are some other tools in this space as well. The other benefit here is by interacting with your application to do codeless test generation, you typically don't need to expose any of your application code because the AI is interacting with your app the same way a user would. It's not generating tests based on your code base the same way that you do for a unit test or code generation tools in your IDE. The second use case here is synthetic data generation. So who here has had to manually update test data for their automated tests? I'm sorry, I've been there, I feel your pain. When I was at Cypress, I did an entire 2-hour workshop on test data management because that is one of the most complex and painful parts of maintaining an automation test suite. And it goes back to that issue of maintenance. Every time something changes in your application, you have to ensure that not only the tests that you are running, but the data used within that test environment matches up with your system. So this is an area where synthetic data generation using AI can be very helpful as an efficiency, to increase efficiency. What it does is it replaces manual or scripted test data creation and maintenance. Again, it goes through 3 steps. The user will input real data into a machine learning software from your application. The ML software will automatically learn patterns in the data, and then the software will output data that contains those patterns. This can be helpful because it matches the statistical properties of your real data. So say, for example, in your database, it knows that 20% of your users tend to have admin access, or 40% of the transactions that you have are in a specific geographical region. The synthetic data that it creates will match those statistical properties to best represent your real production data. This is helpful for industries that have sensitive data because once it's trained, you're leveraging synthetic data generation and not any, obviously, real data. And again, that mantra of like retrain instead of maintain. If you make major changes to your application that requires new data, or if you add new entities to your database, or you change a model of some sort, you just put the new real data into the system, it retrains, and it adapts to those changes. So MIT Synthetic Data Vault is an open source ecosystem for operating this. Those 3 steps that I outlined earlier come directly from the Synthetic Data Vault. So this is something that you're able to leverage in order to train your own model to create test data based on your real data. And this is something that is having real implications for test data across organizations. So this it saves time with automation, and it also increases adaptability. So for example, if you're doing maybe potentially like testing out new changes, you can try different versions of your data model. If you want to see if something will impact it, you could create test generation data that applies to different types of models. There's also some other solutions that are various levels of paid or non-open source. Things like Tonic, LeapWork, and Mostly are also in this space of synthetic data generation. All right, so let's talk quickly about the build process. The build process in the DevOps lifecycle doesn't have quite as many applications of AI yet. So we're going to talk about automated review analysis. Automated review analysis, this takes the data from your static scans that may take place right before your build process or during your build process, and it leverages AI to identify insights and recommendations based on what it finds. So many of you are probably doing automated code quality scanning, security vulnerability scanning, dependency scanning, things of that nature, making sure you don't have any secrets in your code base. You can use these tools to take that data and then get additional insights for what can be improved. This helps you to detect any final issues before deployment that maybe were not caught during the coding part where you're leveraging IDE, or during the testing phase where you've done user acceptance testing, because this is using the additional data coming from those scans. So some examples of this are DeepSource has an autofix AI, and then there's also Graphite Reviewer. Some of these are plugged directly into your CI/CD. So if you create a pull request, it does your scans, and then it will create an additional comment or a notification or alert if it identifies insights based on that data. This is still a pretty new space, and I think that we'll continue to see some more opportunities for improvement in the build step using AI. All right, we've reached deployment. So deployment is a really interesting space for leveraging AI because it is probably one of the more risky places to use AI. Deployments obviously have a lot of impact whenever you push a change, and it can be an area where you may be kind of the most concerned or hesitant to implement AI, and that's for good reason. So there are some things that we're starting to see at this stage of the SDLC using AI, but a lot of them are actually involved with reducing risk. And so we haven't seen many tools that try to automate when deployments happen based on AI, but rather deployment verification using AI after a deployment has taken place. So what this does is it automatically reviews logs and metrics after a deployment. It will then use machine learning to group similar errors together and then compare them against previous versions of your application. And then it will automatically roll back if those errors our metrics are outside an acceptable range. So the example that we're going to take a look at is Harness has a continuous verification tool that leverages ML in order to monitor specific things after a deployment happens. This plugs into your existing CI/CD. So here is an image of what gets generated. So what happens is it consumes all of your logs, and if you have any external metrics, anything that's taking place after a deployment, and it lets you it identifies any errors, load times, a variety of different data, and any errors that come up, it uses ML in order to create this kind of graphical representation of all of the errors that are taking place. Once it does that using machine learning, again, it will compare it to previous versions, and it will say, is this inside, outside an acceptable range? How does it compare to the previous version? And also, where are these errors or maybe potentially like performance issues generating from? Is it an area of the application that we're typically used to seeing or not? And the thing that's interesting here is that it leverages a multiple kind of levels in order to do this. And again, if it identifies that it's outside an acceptable range, it'll automatically roll back to a previous version. So again, AI is kind of being used more not to push things out, but to kind of check things after it's taken place. The other aspect that we're seeing is self-healing pipelines. So this is involving something that's available in multiple CI/CD tools. You may have already seen this in some of your tooling that exists. But it essentially, whenever a build error happens during your pipeline or a step fails, it'll submit those as well as any additional logs to an LLM for analysis. It'll typically try to recommend a root cause and then solutions. This is essentially the same as if you manually had a build or an error in your pipeline, copy and pasted that error message and popped it into ChatGPT, and then also uploaded your log file, and then said, hey, what went wrong? Why did this fail? How can I fix it? But it happens automatically in the pipeline instead. And so the thing about these is they can also be agentic. Some CI/CD providers or tools allow you to interact with a chat environment in order to ask follow-up questions or research further solutions. Some of them are just like a comment that we'll post on a PR. So some examples of this, GitLab Duo has a root cause analysis, and then NX has an explain with AI where it will, this is the GitLab Duo. This is an agentic example where you can ask follow-up questions of example fixes and root cause analysis. The NX explain with AI will add a comment with, hey, we think this is why it broke. All right, so finally, let's talk about monitoring. So here, we're going to talk about two different things. Anomaly detection and analysis will be the first. So anomaly detection and analysis allows you to consume logs via your API, via an API, and then use prediction-based anomaly detection. So the example that we're going to look at is Dynatrace Davis AI. Anybody here using Dynatrace for your monitoring? Yes, so this is something that's built into Dynatrace. So if you were already using it, you install essentially something in your environment that connects to those logs, or you can also stream logs via an API to Dynatrace. And what it does is it creates a multi-dimensional baseline of how your application is performing. When we say multi-dimensional baseline, what that means is it's not just taking a look at what user action caused a specific error to occur, or a performance issue to occur, or a load issue to occur. It also takes a look at your browser and the geographic region of that error. Based on these three factors, it uses machine learning to then define what it considers an acceptable baseline for your application as it normally is. Then, when something happens that's outside of that, it uses predictive analysis to compare it, again, to previous versions of your application to identify and make root cause analysis in a predictive manner. It can also be leveraged in order to predict future outages based on changes. So if it continues to see decreasing reliability in a certain area or geo or user action of your application, then it can predict that there may be additional issues in that area of your application going forward. And then finally, we'll talk about agentic observability. So agentic observability allows you to leverage agents that are trained on your observability data in order to accomplish DevOps tasks. Again, this is like interacting with ChatGPT. However, the model that you're working with has access to every single piece of data from your observability platform that allows you to then complete specific tasks related to data analysis or reliability analysis. So for example, you can ask it to explain stack traces or error logs, summarize performance issues, and also query activity data with natural language processing. So for example, tools like New Relic, Elastic AI Ops, and Splunk AI Assistant have this agentic observability tooling where you can say things like, what errors have we seen in this geographic region over the last 30 days, and how does it compare to the previous 30 days, and using natural language to be able to interact with your observability data. This is something that we're seeing like a lot of times built into platforms or that you may already be using. So if you're already using New Relic, Elastic, or Splunk, this is typically an add-on that allows you to have that agentic experience. Okay, so we talked about a lot of different features across the software development lifecycle where you can implement AI. Now, the thing, I feel like if you're in engineering leadership, like I mentioned earlier, engineering leaders are feeling the pressure to start putting AI everywhere. And that's something that if they may want to say, okay, let's go ahead and do all of this. Let's make it all happen, right? But there's a lot of considerations that you need to look at when you're implementing AI anywhere in your software development lifecycle. Because as I mentioned earlier, we've seen what the issues are that come just from code gen and just within that one part of the SDLC. So if you start implementing it all over the place, you may have to think about things, like centralized tooling and data, tooling sprawl, dedicated platform team, what redundancies are there. I mean, when I say a lot of considerations, there are a lot of considerations. And so the least of all is not hallucinations, right? And so it's something that it takes a very measured approach, and I would argue for an incremental approach, because we didn't see that with code gen. We went from nobody is using code gen, it's not allowed, to 81% of software developers using code gen in the SDLC very, very quickly, like very, very quickly. And as we're seeing, that's causing a lot of issues when it comes to debugging time and increased incidents and security vulnerabilities. So we don't want to repeat that behavior with other aspects of the SDLC. So as you take a look at these various considerations and design a plan, there are some specific approaches that you can take for identifying where to implement AI in your own software development lifecycle at your organization. So it's important to think about the fact that AI is an accelerator. So if you're looking at your SDLC and you're saying, where should we implement AI next? Think about, when it comes to your organization, what areas will benefit from acceleration, right? Because it's not necessarily a bad idea to start with the worst performing areas of your software delivery lifecycle. However, it's important to understand why those areas are low performing. So if it's a problem that can be fixed by accelerating the workflow, then great. But if there's organizational, structural, or other issues that need to be fixed before integrating AI, then accelerating that aspect of your workflow may only cause additional issues. So for example, one of the examples I mentioned earlier, if there's an influx of code change occurring due to code generation, but your bottleneck is in testing, AI test and generation could make more sense as a starting point than going directly to something more in the deployment phase. So the first thing that you really need to do is assess your existing workflows, understand which ones are low-performing areas that could benefit from AI, and also understand that if it's an accelerator is what you need or not. And this is all going to depend on your existing limitations and your existing culture. So, what changes need to be made before you can implement AI? Do you have specific training or security or change management needs that you need to update? Is your infrastructure ready to implement AI? What access to existing tools do you have? Do the right teams have access to the specific data that you need? And this is essentially a digital transformation. So you should tailor your implementation strategy with that same mindset. So how many of you have ever gone through like a cloud migration or any other kind of digital transformation change at your organization? It didn't take overnight, right? Those take a long time. There's a lot of governance and processes that need to go in place to make sure that that's going to go smoothly for you. So really, this is all about risk management. Legal, compliance, and security teams will need to be established in order to create governance policies related to the data that goes in and out of your AI tools. So I mentioned it may have had some alarm bells going off in your head a few times at some of these things that I mentioned. One of them may have been putting real production data into an ML to train your test generation model. So that may be something that is a no-go, or that may require very, very specific infrastructure requirements to ensure that no PII ever makes it to a public model or anything that could be exposed externally. Another thing that you may have heard is analyzing all of your logs and your observability data in order to do prediction-based analysis. That may be more of an infrastructure overhead issue, where if you have a variety of different tools that you're using or a variety of different systems that all have their own logs and monitoring, if you're feeding that into a AI tool, is that going to increase the resource utilization at your organization, increase costs that may not necessarily offset the productivity gains or the risk reduction that you get from introducing that? So some of the things that I mentioned that sound really great and, oh, they have all these cool things you can do, there is very much a potential trade-off if it's not implemented the right way. And so a recommended approach is a phased approach that prioritizes where you have the easiest points of integration. So where in your system would it make the most sense to be able to plug something in, but then remove it easily? So it needs to be something where you can, versus rebuilding a new system, starting from scratch, where are the areas in my SDLC where I can isolate very easily, try it, go in, go out, if, kind of like quick in and out if there's an issue. And there's probably not a lot of places in your SDLC where that's very obvious, Depending on your organizations, some may work better than others, but you want to avoid what we call kind of the shadow AI, which is what we've seen a lot so far with code gen. Like, a lot of organizations don't even necessarily know what AI tools that their developers are using to generate code. If they're using specific, IDEs, they may have some insight into that, but if you're copying and pasting or using agents, there's just kind of this shadow activity taking place where AI is being integrated. The good news is that that's much harder to do with other aspects of the software development lifecycle because of the access to data that you need and access to your infrastructure that you need. But it's important to try to avoid having that happen where developers or individuals are interacting and implementing this on their own. So again, it's also really important to make sure that you have correct logging and data identification in place so if something does go wrong, you know why. AI should never touch your system in a way where you cannot identify the root cause of an error. That's pretty much a table stakes whenever you start to implement something. And we don't see that with code gen. Sometimes if we use AI code gen and there's an error, we don't necessarily know what tool created that code. And then that's why the developers are spending more and more time debugging. So again, we don't want to repeat that when it comes to the other areas of the SDLC, especially since there's the increased risk aspect of it. So I'd like to talk a little bit about how we approach integrating AI into the software development lifecycle at OutSystems. So OutSystems, as I mentioned, is a full-stack low-code platform for building web, mobile APIs and workflows. And we have essentially approached this in a way of what we call the generative software cycle, where AI is implemented across the entire SDLC, not just with the generation of applications. And it's something that we've identified that there's a need to leverage AI as much as possible across the entire SDLC in order to maintain that consistent efficiency. And so what this looks like, and I won't spend too much time here because I want to make sure we have time for questions. And if you have more questions, you can feel free to let me know. But we do have generation, and it is app generation using Gen AI. This is different from code generation in that because we are a low-code platform, we're not actually creating any text or code. Instead, we're using pre-existing components from UI, logic, and data queries in order to build out applications. We do allow you to connect with additional data sources, but this helps to reduce some of those risks that come with traditional code generation. Another example is iteration, which allows you to evolve your apps with AI-powered suggestions. So here we actually use context-aware suggestions in order to add new features to your application. You'll see this in IDEs as well. Copilot may make suggestions, hey, like you should add this feature or try this out next. So we do that as well, but we do it in a low-code way where you're leveraging existing roles and features or screens based on your existing data model with role-based security access for governance controls. And then on the lifecycle management aspect, we use AI to validate and maintain apps using the AI-powered reviews. So I mentioned earlier about the various automated code reviews. We do that as well in OutSystems with code analysis and security vulnerability patching, and also identifying potential errors over time and patterns in order to, for example, you have a specific part of your application, or there's even a specific widget that the way it's configured currently is not performant. It'll continually review to allow you to collaborate for fixes. So again, this is something that we just actually rolled out last month, general availability. So we're looking for early adopters to make apps with it and give us some additional feedback, but we have had some great productivity gains based on the early adopter program insights. And you are able to check it out. We do have free developer accounts. We'd love for you to go in and make apps, test it, try to break it. We're curious to see what types of applications people will generate with it in order to understand what the different use cases are. And it also helps us to better understand what the various vulnerabilities are or errors that may occur during the review and analysis phases as well. All right, so some key takeaways from, just to recap before we get into the questions. Again, AI absolutely must go beyond code gen to have real software development impact. If you've taken nothing else away, take that back to your organization. And if you're only using AI for code gen and nowhere else in your SDLC, I encourage you to look for those opportunities of where AI can be an accelerator to prevent any kind of bottlenecks or restrictions. We also talked about some use cases of AI. Oh, sorry about that. So we talked about some use cases of AI across the software development lifecycle, including the test phase, the build phase, the deploy phase, and the monitoring phase. Things like synthetic test data generation, autonomous codeless test generation, self-healing pipelines, deployment verification, and agentic observability. And then we also talked about how you can take an incremental approach to adoption and the various considerations that you need to think about at your own organization. And then we also took a look at the generative software cycle with Mentor and how we approach that at OutSystems. All right, well, thank you very much again. You can access the slides via the QR code I shared at the front, or feel free to come by the booth and say hi. And I'm happy to take any questions if anybody has any. Thank you.